Hello everyone, welcome back to my channel. Today let's go over a medium question that I just solved on my own. So I'm really glad that I was able to come up with my own solution to this problem without any help. And yep, so I found this one pretty intuitive actually, so let me show you how I did it. This one's called maximum product of first and last elements of a subsequence. So basically just get all the subsequences of size m, and whatever the first and last element, just multiply them and find the largest one, right? So pretty easy. The first way I did it was coming up with a brute force approach. So we have negatives and positives. So let's just get all these subsequences. So you can use combinations of nums of size m, and then update answer if the first and the last element of whatever array you have is bigger than the historic, and then you just return answer at the end, right? So let's run this. Okay, submit it. And this is obviously n to the power of n, which is a lot, so this is going to get time limit exceeded. So let's wait for it to time out. And the next thing I figured out was, okay, so it looks like we're just looking for combinations of m because we're looking for the biggest and the last elements of size m. So basically m is supposed to be 1, so basically we start here and then we look at everything from m to the end, because combinations are going to be like this and this and then this and everything else. So basically what I figured out was just go loop through, and for j in range I plus m minus 1 to length of nums, and then you can do the same thing. So this is a little bit better, nums of I times nums of j, and then you just return answer at the end. Okay, so this is still n squared. So basically, for example, you'll notice that everything from m minus 1 to the end, basically distance-wise from the current element, is fair game, and you're almost there. So basically, this can be turned into n by basically, you notice that we're just removing one element each time. So we start from m minus 1 to the end. So let's call this current is nums of m minus 1 to the end. And let's make this a q because we want to pop. And then each time you'll notice that we just want, if cur is not empty, then we just pop left. And then here we can just say answer is max of answer nums of I times minimum of cur, because you know they're negative numbers, so nums of I times max of cur. So think like Cadane's algorithm. And basically let's just go ahead and print current so you can see what I'm talking about. Okay, so if current, okay, cool. So notice how it gets one shorter each time, because m is 1 in this case, because we're starting from at least m minus 1 to the end. So here 3, that means start on index 2 and then keep going shorter by 1 each time, right? Because that's how combinations work, because if you were here, then all combinations of size m means literally any other number. Here, basically the total number of numbers in that combination has to be m. So let's submit this. Okay, output limit exceeded. Oops. Submit it. Okay. Okay, time limit exceeded again because this min and max is probably taking too much time. So what we're going to do is create a sorted list of cur, and then we want to pop the rearmost element, so the value is cur 0, right? And then we just discard that from the sorted list, because now the sorted list is like a balanced binary tree. It's going to keep everything in sorted order at all times of this list, so that's really handy. And then we can just, you know, the 0th, the leftmost is the smallest, and then the rightmost is the largest. So if we print SL, you'll see. Cool, so you notice how this is always in decreasing to increasing order, right? Okay, so, and it's also a copy of cur at any time, so that's really handy. So that was the idea that I came up with. As you can see, sorted, not sorted. This is the original cur. Okay, so let's submit this. And there you go, passes all test cases. Again, I'm really glad that I was able to come up with my own solution to this problem without any help and solve it on my own. Even though the runtime and memory are not great, again, this channel represents my own work, and so I'm pretty proud of that. So that's it for this video. Thank you for watching and stay tuned for more.